Okay guys, let's talk about the questions now over trigonometric functions. Find the value of this particular trigonometric ratio, that is cosec 390 degrees. Now obviously here if it is given cosec 390, try to break it up in the form of or with the help of allied angles. When I do that, the closest to this is obviously 360. So I break it up as 360 plus 30. Now if you remember in radian, 360 is written as 2 pi and 30 is written as pi by 6. I know cosec 2 pi plus theta is cosec theta, isn't it? Cosec 2 pi plus theta is cosec theta. If this is my theta, cosec 2 pi plus theta is cosec theta, right? Which is nothing but 1 upon sine theta. Cosec and sine are reciprocals actually. What is sine pi by 6, that is sine 30, is 1 by 2, and so you get 2 as your answer. Next question says, find the value of sine 75. Now 75, if I try any allied angle in here, 90, 180, 270, 360, the theta that is going to be coming up won't be one of those angles, acute angles, which is one of those basic angles wherein I know the value of sine, right? If you break it up with the help of 90, basically 90 minus 15 is going to give you 75. So 90 minus theta you can use, but then 15 is an angle at which I don't know the very value of sine cos. Therefore, in order to tackle this type of trigonometric ratios in which I am not able to use any basic angle and allied angle to actually break this up and hence compute the value, we use a different approach. This is sine 75. Clearly I can write it as sine 30 plus 45. Both are basic angles. Use the formula of sine of A plus B. I know sine of A plus B is sine A cos B plus cos A sine B. Sine A cos B plus cos A sine B. So this will be sine 30 cos 45 plus cos 30 sine 45. Sine 30 1 by 2, cos 45 1 by root 2. Cos 30 root 3 by 2, sine 45 1 by root 2. So you get what? 1 by 2 root 2 plus root 3 by 2 root 2. LCM is 2 root 2. Your answer is 1 plus root 3 by 2 root 2. So your answer of sine 75 is 1 plus root 3 by 2 root 2. Next question says that solve this particular trigonometric equation. In here, if you remember, sine square and cos square, if two trigonometric ratios are given in here, and if I have the very methodology to write one in terms of the other, of course I am going to use that. If I know that sine square theta plus cos square theta is 1, obviously I can write cos square theta as 1 minus sine square theta. So I will be having 7 into 1 minus sine square theta plus 3 sine square theta equals 4. Now everything is in terms of sine square. Situation is pretty simple for us. This becomes 7 minus 7 sine square theta plus 3 sine square theta equals 4. 7 minus 7 plus 3 is minus 4 sine square theta equals 4. 7 minus 4 is 3, you get 3 by 4 equals sine square theta. 3 by 4 can be written as root 3 by 2 whole square, but root 3 by 2 is sine 60. So sine 60 whole square. You have got, what have you got? I know that sine square theta equals sine square alpha implies, this is alpha, sine square theta equals sine square alpha implies theta equals n pi plus minus alpha, where n is an integer. That is what is the solution of this particular trigonometric equation, where alpha is a specific angle and theta is that angle, such that sine square theta equals sine square of this specific angle alpha. In that case, theta has to be equal to n pi plus minus alpha in order to deliver sine square theta equals sine square alpha. Here I have sine square theta and this is sine square alpha, where pi by 3 is playing the role of alpha, and so my answer is theta equals n pi plus minus pi by 3. Fine, that is how you solve this trigonometric equation. Next question we have, if a plus b is pi by 4, prove that 1 plus tan a into 1 plus tan b is 2. How are we going to prove this? A plus b is given to be as pi by 4. Okay, pi by 4. I know tan pi by 4 is 1. So I am going to use that. If a plus b is pi by 4, tan of a plus b is tan of pi by 4, which is 1. Tan of a plus b is tan a plus tan b upon 1 minus tan a tan b. This is equal to 1. This means you have got tan a plus tan b equal to 1 minus tan a tan b. Simply, right? Bring it on the left hand side. You have tan a plus tan b plus tan a into tan b equal to 1. I want this to be equal to 2. If I add 1 on both sides, what will I get? 1 plus tan a. Tan b you can see is coming out common from here. Inside you have 1 plus tan a equal to 2. This is 1. If nothing is there, I can write 1. So you are left with 1 plus tan a into 1 plus tan b equal to 2. Hence proved. The only identity that I have used is this one. And apart from this, it's just simplification. Tan of a plus b is tan a plus tan b upon 1 minus tan a tan b. Moving to the next question, we have prove that tan 70 is equal to tan 20 plus 2 tan 50. How can you obtain this? In here, just try to understand 50 is 70 minus 20. So somehow tan of a minus b is being given relevance over here. If I talk about tan of a minus b, it is tan a minus tan b upon 1 plus tan a tan b, right? So that means tan a minus tan b is equal to tan of a minus b into 1 plus tan a tan b. Tan a minus tan b is tan of a minus b into 1 plus tan a tan b. If I take a as 70 and b as 20, I get tan 70 minus tan 20 is equal to tan of 70 minus 20 1 plus tan 70 tan 20. Right? This gives you tan 50 on the right hand side, which is something that you want. You are seeking for tan 50, right? I have actually obtained tan 70 minus tan 20 by taking tan 20 on the left hand side. I need to prove tan 70 minus tan 20 is 2 tan 50. Now tan 50 has already been obtained, tan 70 minus tan 20 is obtained. Somehow this thing need to be converted into 2. Then you will have tan 70 minus tan 20 is tan 50 into 2, that is 2 tan 50, and your claim will be actually proved. So somehow this needs to be converted to 2. How am I going to do that? Now, you know that tan 20 can be written as tan 90 minus 70. And tan 90 minus theta is cot theta. So I can write tan 20 equal to cot 70. Tan 20 is nothing but cot 70. This gives you tan 50. You have 1 plus tan 70. Cot 70 is nothing but 1 upon tan 70. Tan 70 cancels out. You are having 1 from here and 1 already here. 1 plus 1 is 2. You have got 2 tan 50. And therefore, tan 70 minus tan 20 is 2 tan 50, or I can say tan 70 is tan 20 plus 2 tan 50. Clear? Next question says that if tan A minus tan B is x and cot B minus cot A is y, then prove that cot of A minus B is 1 by x plus 1 by y. Okay. Tan A minus tan B is x and cot B minus cot A is y. Let's try to begin with cot B minus cot A, because cot will be written in terms of tan and then we will be using the given information about tan. So, cot B minus cot A is y. That means 1 upon tan B minus 1 upon tan A is y. See, if you are comfortable with tan, which most of us are, just convert everything in terms of tan because it is possible. This gives you tan A minus tan B upon tan A tan B equal to y, right? Tan A minus tan B is given to me as x upon tan A tan B is equal to y. This means tan A tan B is equal to x upon y. I need to compute the value of cot of A minus B. See, cot of A minus B, again, comfortable with tan, convert it in tan. Same as 1 upon tan of A minus B. Tan of A minus B is tan A minus tan B upon 1 plus tan A tan B. Because tan of A minus B is in the denominator, so I have reciprocated the formula of tan of A minus B. Now 1 plus tan A into tan B is given as x upon y, whole upon tan A minus tan B is given as x. So this is y plus x upon xy, y upon xy plus x upon xy. This is 1 upon x plus 1 upon y. You have proved that cot of A minus B is 1 upon x plus 1 upon y. Is it clear? Next we have sin x is 3 by 5, cos y is minus 12 by 13. X and y are lying in the second quadrant. Please note this point. X and y are lying in the second quadrant. Find the value of sin of x plus y. If I focus upon this expression, what is sin of x plus y? Sin of x plus y. Sin of A plus B is sin A cos B plus cos A sin B. I am already having sin x and cos y. I am having sin x and cos y. I don't have cos x and sin y. Let's compute cos x and sin y and then plug it in everything over here to compute the value of sin of x plus y. See, sin x is given to me as 3 by 5. Cos y is given to me as minus 12 by 13. This I don't know, this I don't know. Sin x, if it is 3 by 5, from here I can compute cos x. How? I know cos square x plus sin square x is 1. So, cos square x is 1 minus sin square x. That is 1 minus 3 by 5 whole square, which is 1 minus 9 by 25, that is 16 by 25. 25 minus 9 is 16, 16 by 25. If cos square x is 16 by 25, cos x is plus minus 4 by 5. I am just taking square root of 16 by 25, that is 4 by 5 with a plus minus sign. X is lying in the second quadrant and x belongs in the second quadrant. In the second quadrant, according to sign convention, cos is positive or negative. If the angle is lying in the second quadrant according to ASTC rule, In the second quadrant, sine and cosec are positive, rest everything is negative. So if x is lying in the second quadrant, cosine ratio is negative, where cos is negative. This implies cos x will be equal to minus 4/5. Fine. After that, if you have cos y with you, you can find sin y, because sin square y plus cos square y is 1. So sin square y is 1 minus cos square y. Now cos square y will be 144 upon 169, because it will be square of minus 12/13, which is square of minus 12, that is 144, square of 13, which is 169. This gives you 25/169, and therefore when you take the square root, you get sin y equals plus minus 5/13. Y is also given to be in the second quadrant, where y belongs in the second quadrant. In the second quadrant, sine is positive, where sine is positive. This implies sin y is not minus 5/13, but it is plus 5/13. So I have got the value of cos x and sin y. Plug it in over here. Cos x is minus 4/5 and sin y is 5/13. When you resolve this, you get minus 56/65. Fine? And that happens to be your very answer to this query. Okay? Moving to the next. We have prove that this expression is equal to sin 5x into sin 5x/2. Okay, let's begin understanding. See over here, cos of 2x multiplied by cos x/2 is given to you. That means cosine is given in product. Do I have any formula related to cosines given in product? Cos A cos B types? Of course we have. 2 cos A cos B is cos of A plus B plus cos of A minus B. If I just multiply 2 over here, it will be 2 cos A cos B, I will be able to apply the formula. 2 cos A cos B, I will be able to apply the formula. So let's do that. I divide and multiply by 2, I get 2 cos 2x cos x/2. 2 cos A cos B is now built up. Then you have minus 2 cos 3x cos 9x/2. Again 2 cos A cos B build up. So this is 2 cos A cos B, cos of A plus B plus cos of A minus B minus cos of A plus B plus cos of A minus B, but because of this minus sign it will be cos of A minus B. Resolve this out, you get 1/2. This is 4x plus x, 5x/2 plus cos of, this is 4x minus x, 3x/2 minus cos of 3 into 2, 6, 6 plus 9, 15, 15x/2 minus cos of 6, 3 into 2, 6, 6 minus 9 is minus 3, so minus 3x/2. But cos of minus theta is same as cos theta, so no relevance of this minus sign. You can see I have cos 3x/2 minus cos 3x/2, they both cancel out. I am left with 1/2 cos of 5x/2 minus cos of 15x/2. Clearly over here cos C minus cos D is applicable. Cos C minus cos D minus 2 sin C plus D/2 sin C minus D/2, right? So this is equal to minus 2 sin C plus D, that is 5x/2 plus 15x/2 by 2 minus 2 sin C plus D/2 sin C minus D by 2. Fine. This is minus 2 sin 5x plus 15x is 20x/2, that is 10x. 10x whole upon 2 is 5x sine. 5x minus 15x is minus 10x by 2 minus 10x by 2, that is minus 5x by 2. Sine of minus theta is minus sine theta. This minus will become plus. This 2 cancels out. You are left with sine 5x sine 5x by 2. So you have got sine 5x by 2 on the right hand side. Clear? Next we have question number 9. It says find the value of tan pi by 8. Let's compute the value of tan pi by 8. Directly we don't know, we just know that pi by 8 lies in the first quadrant. So tan of pi by 8 will be a positive value, right? Because in the first quadrant every trigonometric ratio obtains positive value. So what I do is I just take pi by 8 equal to x, then 2x will be equal to 2 times pi by 8, which is pi by 4. I need to compute tan pi by 8. What is tan 2x? Formula for tan 2x. It is 2 tan x upon 1 minus tan square x. Tan 2x means tan 2x is pi by 4. Tan pi by 4. 2 tan pi by 8 upon 1 minus tan square pi by 8. Tan pi by 8 we need to compute. Tan pi by 4 is nothing but 1. If I take tan pi by 8 as y, that means I have 1 is equals to 2y upon 1 minus y square. If I take tan pi by 8 as y, this means 1 minus y square equals 2y, or I can say 2y plus y square minus 1. That is y square plus 2y minus 1 equals 0, which is a quadratic equation in y. Let's find out the solution, because the solution will be the value of y, and y is nothing but tan pi by 8. So the solution of this equation will give me the value of tan pi by 8. So therefore y is minus b plus minus root over b square minus 4 into 1 into minus 1 upon 2. This gives you minus 2 plus minus root 8 upon 2. This is minus 2 plus minus. What happens over here? Root 8. If I talk about root 8, what is this? This is 4 minus 4 into minus 1. Why? B square is 4. B square minus 4 into 1 into minus 1. So 4 into 1 into minus 1 is 4 into minus 1, that is minus 4. 4 plus 4 gives you 8. 8 you know is 2 root 2. Square root of this gives you again 2 root 2, because it is square root of 2 into square root of 2. Basically, when you compute this value, you actually get 2 root 2. Or if you separately need to compute b square minus 4ac, you can do that. B square gives you 4, minus 4 into a is 1 and c is minus 1. This gives you 4 plus 4, which is 8, that is positive. Okay? Minus b plus minus root over b square minus 4ac upon 2a, and that eventually lands you to get the very value of y as what? This is minus 1 plus minus root 2. Now either minus 1 plus root 2 is the answer, or minus 1 minus root 2 is the answer. This is the answer or this is the answer, depends upon what is y. Y is tan pi by 8. Pi by 8 lies in the first quadrant. Tan pi by 8 is positive. So what do you think will be the answer? The answer has to be this, because root 2 is 1.414. 1.414 minus 1 is going to give you a positive answer, but minus 1 minus 1.414 will give you a negative answer. So obviously tan pi by 8 is equal to minus 1 plus root 2, or root 2 minus 1 you can say. Therefore, tan pi by 8 is root 2 minus 1. Quickly note this down, understand the justification, and then we are going to tackle the very last question. So in here basically We have just applied our quadratic formula the moment we have obtained the quadratic equation in y. Right? I have applied the quadratic formula minus b plus minus root over b square minus 4ac upon 2a. When I talk about b square minus 4ac, as I was saying, it is coming out to be 8. I know root 8 can be written as root over 4 into 2, which is root 4 into root 2. Root 4 is 2, and therefore you get root 8 as 2 root 2. Fine, and that is what I have directly from here to here I have come, assuming you would be knowing, but okay, that's the justification for it. Root 8 is 2 root 2. The moment I have got this 2 comes out common, you are left with minus 1 plus minus root 2 upon 2. The common 2 and the denominator 2 cancel out, you are left with minus 1 plus minus root 2. After that, we have got two values. Tan pi by 8 comes out to be root 2 minus 1, since pi by 8 lies in first quadrant, which implies tan pi by 8 is positive. Is it clear? Moving to the last question we have, prove that this expression is equal to 3 by 2. Let's prove. Now in here you can see one thing, everywhere there is cos square, cos square, cos square. Do you have any formula related to cos square? If you can recall, 1 plus cos 2 theta is 2 cos square theta. Therefore, cos square theta can be written as 1 plus cos twice of the angle whole upon 2. Let's do this so that we can get rid of this power, because dealing in powers is definitely difficult than dealing with multiple angles. So here if I talk about cos square x, I can write cos square x as 1 plus cos 2x whole upon 2. Then cos square x plus pi by 3 can be written as 1 plus cos 2x plus 2 pi by 3. Right, 1 plus cos 2x plus 2 pi by 3 in here, and then I have cos square x minus pi by 3 plus cos square x minus pi by 3, this will be 1 plus cos, and this is whole upon 2. This is 1 plus cos 2x minus 2 pi by 3 whole upon 2. I have done nothing. Cos square theta I have replaced it by 1 plus cos 2 theta by 2. Cos square x is replaced by 1 plus cos 2x by 2. Cos square x plus pi by 3 is replaced by 1 plus cos 2x plus 2 pi by 3 whole upon 2, and cos square x minus pi by 3 is replaced by 1 plus cos 2x minus 2 pi by 3 whole upon 2. Clearly 1 by 2 is coming out common. Inside you have 1 plus 1 plus 1, that is 3, plus cos 2x plus cos 2x plus 2 pi by 3 plus cos 2x minus 2 pi by 3. Over here if you apply cos c plus cos d, what will you be getting? Cos c plus cos d, 2 cos c plus d by 2, cos c minus d by 2. Let's apply. This is cos 2x as it is. Cos c plus cos d, 2 cos c plus d. Add these two angles, 2x plus 2 pi by 3 plus 2x minus 2 pi by 3. So what do you get? Plus 2 pi by 3 minus 2 pi by 3 cancels out. What are you left with? 2x plus 2 pi by 3 plus 2x minus 2 pi by 3. So 2x plus 2x gives you 4x by 2. 2 cos c plus d by 2 cos c minus d by 2, c minus d, 2x plus 2 pi by 3 minus 2x minus 2 pi by 3, that gives you plus 2 pi by 3. So 2x minus 2x cancels out, you are left with 2 pi by 3 plus 2 pi by 3, that is 4 pi by 3 whole upon 2. So eventually you have, this is 2, this is 2. So you are left with 3 plus cos 2x plus 2 cos 2x cos 2 pi by 3. Can you compute the value of cos 2 pi by 3? Can you do that? Cos 2 pi by 3, it can be very easily computed. This is cos of pi minus pi by 3. Right? Cos of 180 minus theta is minus cos theta. pi by 3 means 60. 60 is 1 by 2. Cos 60 is 1 by 2. So you get minus 1 by 2. I can directly replace cos 2 pi by 3 by minus 1 by 2. So you get 1 by 2, 3 plus cos 2x plus 2 cos 2x into minus 1 by 2. This is minus and just 1 by 2. This 2 cancels out. You are left with 3 plus cos 2x minus cos 2x plus cos 2x minus cos 2x cancels out. You are left with 3 by 2, which is your right hand side. So eventually by just computing the value of cos 2 pi by 3, I got rid of this 2 and created a minus sign over here, which eventually made me get rid of this cos 2x as well with plus and minus sign. Therefore it got cancelled out and I am just left with 3 by 2, which is actually what I needed to show. That completes our discussion over the questions. Please revise them nicely. That's it from my side. Thank you.